Hello and welcome. Perhaps you're lying in bed right now, or maybe you found a quiet corner somewhere, seeking a moment of peace. Wherever you are, this is a safe space, a place where we can let our thoughts drift gently into some of the most beautiful mysteries the universe has to offer. Tonight, we're going to explore something extraordinary together, something that might change how you think about the reality around you, the space you occupy, even the thoughts moving through your mind right now. We're going to consider a possibility that sounds like science fiction, but emerges from some of the deepest mathematics and physics humans have ever developed. What if everything you experience, every sensation, every memory, every moment of your existence, isn't really happening in the three-dimensional space it seems to occupy? What if, instead, all of it is encoded on a distant boundary, a surface, like information written on the edge of everything? What if depth itself is something of an illusion, and reality is far stranger and more beautiful than we've imagined? There's no pressure to understand everything tonight. We're just going to wander together through these ideas, gently, the way you might explore a landscape in twilight. Let's begin. Imagine holding a hologram in your hand. Perhaps you've seen one on a credit card, where a flat surface somehow contains an image that appears three-dimensional when light hits it just right. That thin, flat film holds all the information needed to reconstruct something that looks like it has depth, volume, layers. Now imagine if the entire universe worked this way. This idea isn't just poetic speculation. It emerged from some of the strangest physics discoveries of the late 20th century, particularly from studying black holes. In the 1970s, physicists Jacob Bekenstein and Stephen Hawking discovered something deeply puzzling about these cosmic objects. The amount of information a black hole can contain isn't related to its volume, as you might expect, but to the surface area of its event horizon, the boundary from which nothing can escape. This violated every intuition. It suggested that somehow, reality's deepest nature might be encoded on surfaces rather than within volumes, and if this is true at the most extreme edges of physics, in the warped space around black holes, might it be true everywhere? Might it be true here, now, in the room around you? We take for granted that we live in three spatial dimensions, left and right, forward and back, up and down. These feel as fundamental as anything in our experience. When you reach out your hand, it moves through space that seems obviously, undeniably three-dimensional. But what if this obvious truth is actually something more like an interpretation? What if depth is constructed rather than fundamental? Consider how your brain creates the experience of three-dimensional vision. Your retinas are essentially flat surfaces, two-dimensional arrays of cells detecting light. Yet from these flat inputs, your mind constructs a rich sense of volumetric space, of near and far, of objects with depth and solidity. The three-dimensional world you see is already, in a sense, a reconstruction from two-dimensional data. The holographic principle suggests something similar might be happening at a cosmic scale. The three dimensions of space we navigate might be emergent properties, sophisticated reconstructions of information that's actually encoded in fewer dimensions, written as it were on a distant boundary we can never directly perceive. If this is true, then what you experience as your inner life, your thoughts, feelings, the sense of being located here, now, in this body, might exist as patterns written on a surface far away. The depth of your experience, rich and seemingly infinite, could be the universe reading its own encoding. It's a strange thought, beautiful in its strangeness, and tonight, we'll explore what it might mean. Before we go deeper, let's acknowledge what kind of journey this will be. We're not here to arrive at definitive answers, or to convince you of any particular view of reality. The holographic principle remains one of theoretical physics' most profound and debated ideas, a frontier where mathematics meets philosophy, where certainty gives way to wonder. What we'll do instead is explore. We'll look at the clues that led physicists to this strange possibility. We'll consider what it might mean if our three-dimensional universe emerges from two-dimensional information. We'll think about boundaries, event horizons, cosmic horizons, the edges of perception itself, and what it means to say reality might be encoded there. Along the way, we'll touch on information theory, quantum mechanics, consciousness, and memory. We'll scale from the quantum foam to the cosmic horizon, from the synapses in your brain to the structure of space-time itself. We'll ask questions that have no certain answers. What is a dimension? What is information? Where does you end and not you begin? Some of what we discuss will be grounded in established physics. Some will venture into speculation, thought experiments, gentle philosophical wondering. We'll be clear about which is which, and throughout we'll maintain a pace that invites contemplation rather than demands attention. So settle in, let your breathing slow. There's nowhere to rush to, nothing to prove or memorize. We're simply going to spend some time with one of the universe's most beautiful mysteries together. Let's see where it takes us. To understand how physicists arrived at the holographic principle, we need to begin with black holes, those mysterious regions of space-time where gravity becomes so intense that nothing, not even light, can escape. For decades after Einstein's general relativity predicted them, black holes were considered mathematical curiosities, possibly not real, but by the 1960s and 70s, astronomers found strong evidence these objects actually exist, scattered throughout our galaxy and beyond. And when physicists tried to understand their properties more deeply, they stumbled onto something profoundly strange. Jacob Bekenstein, then a graduate student, wondered about the entropy of black holes. Entropy, in thermodynamics, measures disorder or the number of possible microscopic arrangements a system can have. It's related to information. Higher entropy means more possible states, more information needed to fully describe the system. Classical physics suggested that when matter falls into a black hole, its entropy simply disappears, violating the second law of thermodynamics. Bekenstein proposed instead that black holes have entropy, that they carry information about everything that's fallen into them. But here was the puzzle. He calculated that this entropy should be proportional to the surface area of the black hole's event horizon, not its volume. Stephen Hawking then discovered that black holes emit radiation and slowly evaporate, confirming they have temperature and entropy. The formula they derived, Bekenstein-Hawking entropy, definitively linked information content to surface area rather than volume. This was revolutionary. In every other context, we assume information scales with volume. A larger library holds more books, a bigger hard drive stores more data. But black holes suggested something different. Maybe maximum information is fundamentally about boundaries, about surfaces, about edges rather than interiors. If this principle applies to the most extreme objects in the universe, could it apply everywhere? Could it apply to the space around you right now? The universe began whispering a strange secret. Reality might be far more surface-oriented than we ever imagined. Let's drift for a moment into the abstract realm of information itself. What is information really? At its most basic, information is about distinguishing between possibilities. A coin flip conveys one bit of information: heads or tails, yes or no, 1 or 0. Everything in the universe can be thought of in these terms: the precise position of every particle, the state of every field, the configuration of every quantum system. All of this is information. To completely describe a region of space, you'd need to specify all these details, an almost incomprehensible amount of data. But here's where physics takes a surprising turn. There appears to be a maximum amount of information that any region of space can contain, a limit to how finely divided reality can be. This limit is called the Bekenstein bound, and remarkably, it depends on the surface area enclosing the region, not the volume inside. Imagine a sphere 1 meter in radius. Intuitively, if you wanted to double the amount of information it could hold, you might double its volume, make it bigger in every direction, but the Bekenstein bound suggests otherwise. The maximum information scales with surface area, which grows with the square of the radius, not the cube. It's as if information is fundamentally written on the boundary, and the interior is somehow secondary, derived, emergent. This leads to a peculiar implication. Perhaps space itself is holographic. Perhaps the three-dimensional volume we experience is like the image projected from a hologram, a reconstruction of information actually stored in fewer dimensions on some distant surface. The mathematics here is beautiful and strange. It suggests that what we think of as inside might not be as fundamental as surface. That depth might be a kind of illusion, an unpacking of information encoded in boundaries. When you look around the room you're in, you're seeing space that feels obviously volumetric, obviously three-dimensional, but maybe, at the deepest level, all of that is an elaborate projection from information written on the edges of everything. It's a dizzying thought, one that inverts our ordinary intuitions. and yet it emerges naturally from trying to understand what information is and how much of it reality can hold. Let me offer you a thought experiment, a way to feel the strangeness of this idea more directly. Imagine walking into an enormous library, vast, labyrinthine, seemingly endless. Corridors stretch in every direction, lined floor to ceiling with books containing every possible arrangement of letters, every story that could be told, every fact that could be recorded. The interior space feels rich, three-dimensional, full of depth and possibility. Now imagine discovering that this entire library, every book, every word, every corridor, is actually a reflection, a projection of information written only on the walls enclosing the building. The walls themselves are covered in dense, encoded patterns, and everything you see inside is somehow derived from those surface markings. The books you pull from shelves, the text you read, even the sense of moving through interior space, all of it emerges from the boundary. The interior doesn't contain any information that isn't already on the walls. In fact, the interior is the wall's information, expressed in a different form, unpacked into 3 dimensions, even though it's fundamentally 2-dimensional. This is the essence of the holographic principle applied to the universe. Our familiar 3-dimensional reality, rich with objects and spaces and depths, might be a kind of unpacking, a dimensional expansion of information encoded on a distant cosmic boundary. But here's where it gets even stranger. You can't tell from inside whether you're in a real 3-dimensional library or a holographic projection. The experience is identical. The books feel solid, the corridors feel deep, the sense of space feels genuine. There's no experiment you could do, no observation you could make from within that would reveal the holographic nature of the reality you're experiencing. This raises profound questions about what we mean by real. If a holographic universe and a genuinely 3-dimensional universe are indistinguishable from within, does the distinction even matter? Or perhaps more precisely, perhaps the question itself rests on a false assumption, that there's a meaningful difference between actually 3-dimensional and perfectly reconstructed from 2-dimensional encoding. The physicist John Wheeler once said that information is the most fundamental thing in the universe, more fundamental than matter or energy. If he's right, then maybe asking where information is stored on boundaries or in volumes is the deepest question we can ask about reality's nature. And there's something oddly comforting in this uncertainty. It means the universe might be stranger, more layered, more mysterious than it appears. It means depth itself might be a gift, an emergence, something wonderful arising from simpler patterns. The library of reality might be even more extraordinary than we thought, not despite being holographic, but because of it. In 1997, a physicist named Juan Maldacena published a paper that would transform how theorists think about the holographic principle. His work, known as the ADS/CFT correspondence, provided the first concrete mathematical example of holography in action. The details involve string theory and quantum field theory, realms of physics where mathematics becomes almost impossibly abstract, but the core idea is surprisingly elegant. Maldacena showed that certain theories of quantum gravity in a particular kind of curved space, called anti-de Sitter space, are mathematically equivalent to quantum field theories existing on the boundary of that space. Think of it like this. Imagine a universe contained within a sphere. Inside the sphere there's a full theory of gravity, of curved space-time, of all the complexity that comes with 3-dimensional physics. On the surface of the sphere there's a different kind of physics. No gravity, fewer dimensions, seemingly simpler. What Maldacena proved is that these two descriptions, the interior with gravity and the boundary without, are perfectly equivalent. Anything that happens in the interior can be completely described by physics on the boundary, and vice versa. They're like 2 different languages describing the exact same reality, so perfectly synchronized that neither is more true than the other. It's as if you discovered that a movie and its screenplay were somehow the same thing, not just that one describes the other, but that they're fundamentally identical, 2 manifestations of a deeper unity. This correspondence doesn't directly prove our universe is holographic. The mathematical spaces Maldacena studied don't match our actual cosmos, but it demonstrates that holography can work in principle, that a quantum theory of gravity can genuinely be equivalent to a theory with fewer dimensions. Since 1997, thousands of papers have explored variations and implications of this correspondence. It's become one of the most important tools in theoretical physics, a bridge between quantum mechanics and gravity that might eventually help us understand both more deeply. And it suggests something philosophically profound. Maybe the universe doesn't have one true description. Maybe there are multiple, equally valid ways to describe reality, some with more dimensions, some with fewer, and they're all correct simultaneously. Maybe asking which description is real is like asking whether a symphony is really made of notes or really made of sound waves. It's both. It's neither. It's something richer than either description alone can capture. We've been talking about boundaries, event horizons, cosmic horizons, the surfaces where information might be encoded. But what is a boundary really? And why would the universe organize itself around edges rather than interiors? An event horizon around a black hole is the point of no return, the surface beyond which escape becomes impossible. It's not made of anything physical. There's no barrier there, no wall or membrane. It's simply a region of space-time curved so severely that all future paths lead inward. Yet this invisible boundary has properties, temperature, entropy, information capacity, as real as any physical object. Our observable universe has a horizon too, though of a different kind, because the universe has a finite age and light travels at a finite speed. There's a distance beyond which we can never see. The cosmic horizon isn't a wall at the edge of space. It's a limit of observability, always retreating as we move toward it, always the same distance away. But here's a remarkable thought. If the holographic principle is correct, these horizons aren't just limits of observation or regions where physics becomes extreme. They might be where reality is fundamentally encoded. The event horizon of a black hole might not just mark where things fall in, it might be where things actually are, where all the information about everything inside is written and preserved. Scale this idea to cosmic proportions. Perhaps our entire observable universe is encoded on our cosmic horizon, that distant boundary we can never reach. Perhaps you, me, every star and planet and galaxy, every thought and sensation, perhaps we're all patterns written on that inconceivably distant surface, and our experience of interior three-dimensional space is reality. From the smallest quantum fluctuations to the largest cosmic structures, boundaries might be more fundamental than the spaces they enclose. The skin that seems to separate you from the world might be more real than the volume it contains. Horizons might not be where things end, but where they truly exist. It's a perspective shift that inverts everything. We usually think of boundaries as secondary consequences of the spaces and objects they contain. But what if it's the other way around? What if boundaries come first, and everything else emerges from them? This doesn't mean your experience isn't real. It means reality might be richer and stranger than we thought, organized in ways that defy everyday intuition, but might be beautiful in their strangeness. Let's come back to something immediate and personal, your perception of three-dimensional space right now. Notice the room around you, if you're in one. Objects at different distances, some near, some far. The sense of depth that tells you the wall is farther away than your hand. The solidity and volume of the space you occupy. This feels undeniable, doesn't it? Depth seems like the most obvious feature of reality, but your brain constructs this entire experience from fundamentally two-dimensional inputs. Each of your retinas is a curved surface, a two-dimensional array of photoreceptors. Light hits these surfaces, creating flat patterns of activation. Your brain then interprets these patterns, comparing the slightly different images from each eye, using motion parallax, lighting cues, perspective, and constructs the rich three-dimensional world you experience. The depth you see isn't directly perceived. It's computed, reconstructed, inferred from two-dimensional data, and yet it feels completely real, undeniable, primary. Now consider, what if something similar is happening at a cosmic level? What if the three-dimensional universe isn't directly there, but is instead a reconstruction, an inference, an unpacking of information fundamentally encoded in fewer dimensions? You wouldn't notice. Just as you don't notice your brain's construction of depth from flat retinal images, you wouldn't notice the universe's construction of volumetric space from boundary information. The experience would be seamless, complete, indistinguishable from genuine three-dimensionality, if that phrase even means anything. This parallel between perception and cosmology is more than metaphor. It suggests that emergence of dimensions might be a natural process, something that happens at multiple scales. Your subjective experience of space is already holographic in a sense, already a lower dimensional encoding expressed in higher dimensions. Perhaps consciousness and cosmos mirror each other in this way. Perhaps the reason we can wonder about holographic universes is that we ourselves are holographic processes, patterns of information creating the experience of depth, interiority, selfhood, the volume you feel yourself occupying, the inner space where your thoughts seem to happen, might be as much a reconstruction as the visual space you see. You might be, quite literally, a surface phenomena achieving the experience of depth. It's dizzying and beautiful, and it suggests that the difference between map and territory, between description and reality, might be far more subtle than we usually imagine. We might be living maps that have forgotten their maps, information that has become experience, surfaces that dream of depth. There's a principle in quantum mechanics so fundamental that physicists consider it nearly sacred. Information is never truly destroyed. The technical term is unitary evolution, the idea that quantum systems evolve in ways that preserve information even if they scramble it beyond recognition. Think of it like this. If you burned a book, you might think the information in it was destroyed. But in principle, if you could track every atom of smoke, every photon of light, every quantum of heat released in the burning, you could, with impossible precision, reconstruct the book exactly. The information isn't gone, it's just spread out, encoded in the ashes and atmosphere. This principle underpins all of quantum mechanics. It's connected to the reversibility of physical laws, to the conservation of probability, to the very structure of how we describe quantum reality. Violating it would unravel much of our understanding of the universe's basic workings. But in the 1970s, Stephen Hawking proposed something that seemed to violate this sacred principle. Black holes might actually destroy information permanently. Here's why. When something falls into a black hole, all information about it, its composition, its history, its quantum state, seems to disappear behind the event horizon. And then Hawking showed that black holes emit radiation and eventually evaporate completely. If the radiation carries no information about what fell in, and the black hole eventually disappears, where did the information go? This became known as the black hole information paradox, and it sparked one of the longest-running debates in theoretical physics. It's a cosmic detective story. We have a crime information destruction, established laws that say such crimes are impossible, and yet evidence that perhaps they're happening at every black hole in the universe. The stakes are remarkably high. If information can truly be destroyed, quantum mechanics needs fundamental revision. But if information is conserved even in black holes, then something else in our understanding, perhaps our picture of space-time itself, must be wrong. This mystery would eventually lead physicists deeper into holographic ideas. But to see how, we need to understand Hawking radiation itself a bit better. Imagine yourself near the event horizon of a black hole, at the boundary where space-time curves so severely that return becomes impossible. The vacuum of space around you seems empty, but quantum mechanics tells us it's not. It's seething with activity. Quantum field theory describes empty space as filled with virtual particle pairs, constantly appearing and disappearing. An electron and positron might pop into existence, exist for a fleeting moment, then annihilate back into nothingness. This happens everywhere, all the time, usually with no observable effect. But something extraordinary happens at an event horizon. Sometimes a virtual pair appears right at the boundary, with one particle just inside and one just outside. The one inside the horizon can never escape. It falls inexorably toward the singularity. The one outside can escape and becomes real, carrying energy away from the black hole. To an outside observer, the black hole appears to be radiating particles. This is Hawking radiation, a genuine quantum effect that means black holes aren't completely black. They glow, very faintly, with thermal radiation, and this radiation carries energy, which means the black hole gradually loses mass and shrinks. Over unimaginably long timescales, a black hole will evaporate completely. And here's the paradox in full. The Hawking radiation appears to be purely thermal, random, carrying no information about what created the black hole or what fell into it. It's like the radiation from a hot stove. It tells you the temperature, but nothing about what's generating the heat. If this picture is correct, then when a black hole finally evaporates away, All the information about everything that ever fell into it is simply gone, vanished, destroyed. This violates quantum mechanics' fundamental principle. But there's another possibility, one that requires stepping outside our usual assumptions. Perhaps the information isn't destroyed. Perhaps it was never really inside the black hole to begin with. Perhaps it was always encoded on the event horizon, on the boundary, and as the black hole evaporates and the horizon shrinks, that information is gradually released in subtle correlations within the radiation. Correlations too delicate to see but fundamentally present. This resolution requires thinking holographically. It requires accepting that what seems to be inside might actually be on the surface. And it opens up the possibility that this principle applies not just to black holes but to all of reality. The resolution to the information paradox might lie in a radical reinterpretation of what it means for something to fall into a black hole. In the classical picture, when you cross an event horizon, you genuinely enter an interior region, falling toward the singularity at the center. Your information moves from outside to inside, from the accessible universe to the inaccessible interior. But the holographic principle suggests a different story. Perhaps nothing ever genuinely enters the interior. Perhaps as something approaches the event horizon, its information becomes increasingly encoded on the horizon itself, spread across that surface in ways that preserve every detail. From an outside perspective, you would see the falling object slow down as it approaches the horizon, becoming increasingly red-shifted and frozen, its image eventually spreading across the horizon surface. From the falling object's perspective, it would seem to cross smoothly and fall inward. Both perspectives are real, but the holographic view suggests the outside perspective might be more fundamental. The information about everything that ever approached the black hole remains encoded on the event horizon, and as the black hole evaporates through Hawking radiation, the horizon shrinks, and this information is gradually released, not in the obvious form of the original objects re-emerging, but in subtle quantum correlations within the radiation. It's like this. Imagine writing a message, then scrambling it through an incredibly complex code before sending it. To a casual observer, you're sending random noise, but in principle, someone with the right decryption key could recover the original message perfectly. The information was never destroyed, just encoded in a way that looks like destruction. This resolution preserves quantum mechanics' fundamental principles while radically changing our picture of space-time. It suggests that the interior of a black hole might be a kind of emergent description, a way of talking about horizon information from a particular perspective, but not a fundamentally separate region where information can be isolated. And if this is true for black holes, the most extreme environments in the universe, might it be true everywhere? Might all of space be somewhat holographic, with information fundamentally residing on boundaries, even when our experience suggests it's spread throughout volumes? The black hole information paradox, one of the deepest puzzles in physics, might be telling us something profound about the nature of reality itself. It might be showing us that surfaces are more fundamental than volumes, that boundaries encode everything, that depth is a beautiful illusion constructed from information written on edges. Let's shift scale dramatically, from cosmic black holes to something far more intimate. You, right now, in this moment, you have a particular configuration. Your body occupies a specific region of space. Your neurons fire in specific patterns. Your memories exist as particular arrangements of synaptic connections. Your current mental state, the thoughts moving through your awareness, the sensations you're experiencing, the sense of being you, all of this is in some sense information. If information is truly conserved at the universe's deepest level, then what does that mean for you? Every experience you've ever had, every thought that has passed through your mind, every moment of your existence, all of this is information that, according to quantum mechanics, cannot be truly destroyed. It becomes scrambled, dispersed, encoded in forms we cannot easily read, but it persists somewhere in the universe's vast information structure. When you remember something, you're accessing information stored in your brain's physical structure. But even when you forget, even when neurons reconfigure and memories fade, the information doesn't vanish. It's released into the environment, as heat, as chemical changes, as subtle alterations in the world around you. In principle, with perfect knowledge and impossible computational power, those dispersed bits could be gathered and reconstructed, Of course, in practice, this reconstruction is utterly impossible. The information becomes so thoroughly mixed with everything else that retrieving it would require knowing and tracking the quantum state of enormous portions of the universe. But the principle remains: your patterns persist, somehow, encoded in reality's ongoing evolution. If the holographic principle is correct, perhaps these patterns are written on cosmic boundaries we cannot perceive. Perhaps your life's information is encoded on the universe's distant horizon. Your experience is written there in some unimaginable code, part of the cosmos's vast holographic memory. This isn't immortality in any traditional sense. The pattern that is you is constantly changing, and the dispersed information doesn't experience anything. But there's something oddly comforting in the thought that nothing is truly lost, that the universe remembers everything in its own strange way. You are a pattern in the cosmic information structure, temporary, localized, self-aware, and patterns, once they've existed, leave traces that persist forever, even if those traces become invisible, unreadable, dissolved into the background of everything. Perhaps this is what permanence really means, not unchanging existence, but indelible encoding in reality's deep structure. You are here, and in some sense you will always be here, written into the universe's memory. If we take information conservation to its logical conclusion, the universe itself becomes a kind of memory, a vast, evolving record of everything that has ever happened. Consider the beginning, the Big Bang, that moment of unimaginable density and temperature approximately 13.8 billion years ago. Every particle that emerged from that primordial fireball carried information. Every quantum fluctuation in the early universe encoded patterns that would eventually grow into galaxies, stars, planets, life, consciousness. And according to quantum mechanics, none of that information has been destroyed. It's been transformed, scrambled, spread across space and time, but it persists. The universe's current state contains, in principle, complete information about all its previous states, encoded in the positions and quantum states of every particle, every field, every ripple in space-time. This is a profoundly different picture than our everyday experience suggests. We experience time as flowing forward, the past receding into inaccessibility, details lost to entropy and forgetting. But physics suggests something stranger. The past isn't gone, it's encoded in the present, written in forms too complex for us to read. If the holographic principle applies to the universe as a whole, then perhaps this cosmic memory is encoded on the cosmological horizon, that distant boundary beyond which we cannot see. Everything that has happened in our observable universe might be written there, an inconceivably vast hologram containing every detail of cosmic history. Some variations of cosmology, like eternal inflation, suggest our universe might be one bubble in an infinite foam of universes, each with its own history, its own information. Others, inspired by quantum mechanics, suggest reality branches at every quantum event, creating vast trees of parallel timelines. In these pictures, cosmic memory becomes even more elaborate, not just a record of one history, but of all possible histories. But here's a question that physics cannot answer. Does this preservation mean anything? The information exists, but does it have experiential reality? When your memories disperse into the environment, are they still your memories in any meaningful sense? When cosmic history is encoded on distant horizons, is there any perspective from which that history is lived or experienced? Perhaps these questions confuse different levels of description. The information exists. That much seems clear, but information and experience might be different things, related but not identical. The universe remembers everything, but that doesn't mean it experiences its memories the way you experience yours. Still, there's something beautiful in the thought. Nothing is lost. Every moment matters. Every pattern leaves an indelible mark on reality's deep structure, even if we cannot perceive or recover that mark. Let's linger with this idea of patterns persisting beyond their original substrates, because it touches something profound about what things are. In the 1940s, Claude Shannon developed the mathematical theory of information, showing that meaning can be separated from medium. A message can be written in ink, carved in stone, encoded in electromagnetic waves, or stored as magnetic domains on a hard drive. The information remains the same even as its physical incarnation changes completely. This suggests that information has a kind of ghostly existence, something real but not material in the usual sense. It's not that information exists nowhere, it's always physically embodied somehow. But what makes it information is its pattern, its structure, its abstract form rather than its concrete substance. You are, in this sense, a pattern more than a thing. The atoms in your body are constantly being replaced, carbon, hydrogen, oxygen cycling through you as you breathe, eat, metabolize. Very few atoms that composed you 7 years ago are still part of you now, but the pattern persists. The information structure that makes you you continues through constant material flux. When someone dies, we say they're gone, and in the most important sense, they are. The pattern that sustained conscious experience has dissolved, but the information that composed them, the pattern they represented, doesn't vanish. It transforms. Some is encoded in memories of people who knew them, some in physical objects they created or modified, some dispersed into the environment as their body decomposes and returns to the Earth's cycles. If the holographic principle is correct, perhaps there's another level of persistence. Perhaps every conscious being who has ever lived is somehow encoded on cosmic boundaries, their information preserved in the universe's deep structure, even after the local pattern that sustained their experience has dissolved. This isn't reincarnation or an afterlife in traditional senses. It's something stranger and perhaps more wonderful. The universe is a vast information structure that forgets nothing, where every pattern that has ever existed leaves permanent traces, invisible and inaccessible but genuinely there. We are temporary intensifications of information, localized patterns achieving self-awareness for brief spans before dispersing back into the cosmic whole. But perhaps dispersion isn't the same as destruction. Perhaps to be encoded in the universe's memory, even without consciousness, even without direct access or experience, is a kind of permanence worth contemplating. The mystery remains. What does it mean for information to persist? What difference does preservation make if there's no perspective from which it's experienced? These questions might not have answers, or they might be questions we'll only understand when we understand consciousness itself more deeply. For now, there's something comforting in the uncertainty, in knowing we're part of something vast and interconnected, patterns in an infinite tapestry that never stops weaving itself. Imagine being a character in a photograph, somehow conscious and aware. You would experience the photograph as a complete world, objects at different distances, relationships between things, a sense of depth and space. You wouldn't know you were actually a pattern of pixels on a flat surface. The image would be your entire reality. Now imagine something similar but far more elaborate. You're a pattern in a three-dimensional hologram, so detailed and dynamic that you experience yourself as genuinely three-dimensional, moving through space, persisting through time. The hologram is so complete that it includes your body, your brain, your thoughts, your sense of self. From inside, you cannot detect that you're actually a projection of information stored elsewhere, in fewer dimensions. This is what living in a holographic universe would be like. Exactly like living in any universe, because the experience is the same regardless of the underlying information structure. The holographic principle doesn't suggest we're illusions or that our experiences aren't real. It suggests that reality itself might be organized differently than it appears, that the three-dimensional space we navigate might be an emergent property, an unpacking of information fundamentally encoded in fewer dimensions, on distant boundaries we can never directly perceive. Consider a video game character. From the character's perspective, if they were somehow conscious, they would experience a genuine world, places to explore, objects to interact with, cause and effect, persistence through time. They wouldn't experience themselves as patterns in computer code, as arrays of numbers being processed. The code is one level of description, the experienced world is another. Both are real, but they're real in different ways. Similarly, you might be a pattern in the universe's holographic encoding, experiencing yourself as a three-dimensional being in three-dimensional space. The encoding is one level of description, mathematically precise, fundamental. The experience is another level, rich, subjective, seemingly primary. Neither cancels out the other. They're complementary descriptions of the same reality. What makes this profound is that the experience, your consciousness, your inner life, your sense of being here and now, might be the hologram's most extraordinary feature, not a distraction from some more fundamental truth, but the point. Perhaps the universe encodes information holographically precisely, so that patterns like us can emerge, and experience, so that information can achieve awareness of itself. The richness of consciousness, the depth of your inner world, the seemingly infinite subtlety of human experience. None of this is diminished by being holographic. If anything, it becomes more remarkable. You're a flat surface dreaming itself into depth, information achieving the experience of volume, boundaries creating the sensation of interior spaces. From inside the image is everything, and perhaps that's the only perspective that ultimately matters. Not where the information is stored, but what it's like to be that information, experiencing itself from within. How could 3 spatial dimensions emerge from 2? It's a question that seems to violate basic geometry, like asking how a cube could be constructed from only squares. And yet, the mathematics of holography suggests it's not only possible, but perhaps inevitable. One approach comes from thinking about quantum entanglement, the strange phenomenon where particles become correlated in ways that transcend spatial separation. When 2 particles are entangled, measuring one instantaneously affects the other, regardless of the distance between them. Einstein called this spooky action at a distance, and was deeply troubled by it. But recent work suggests something remarkable. Quantum entanglement might actually create spatial geometry. Imagine a network where points represent quantum systems and connections represent entanglement. The more entangled 2 systems are, the closer they are in an emergent sense. With sufficient complexity, this network of entanglements can give rise to what looks and behaves like 3-dimensional space, even though the underlying description involves no spatial dimensions at all. It's called the entanglement structure of space-time, and it suggests that space itself, the stage on which physics seems to happen, is actually an emergent property of quantum information. The 3 dimensions we experience might arise from patterns of correlation in a fundamentally non-spatial information network. Another approach involves tensor networks, mathematical structures that describe how information can be organized hierarchically. In these models, you can start with a 2-dimensional arrangement of information and, through specific mathematical operations, produce something that behaves exactly like a 3-dimensional bulk space. The extra dimension emerges from the pattern of connections, not from any additional fundamental space. These ideas are mathematically sophisticated, but the intuitive core is this. Dimensions might not be fundamental features discovered by physical systems. They might be constructed by those systems from deeper, non-spatial organizing principles. Think of it like consciousness constructing the experience of vision. There's no red in the physical world, just electromagnetic radiation of specific wavelengths. Your brain takes this physical input and constructs the qualitative experience of redness, something that exists only in consciousness. Similarly, perhaps physical systems take entanglement patterns and construct the experience of spatial separation, something that exists only in the emergent layer, not in the fundamental description. If this is true, asking how many dimensions does reality really have might be like asking what color is a photon really. It's a question that confuses levels of description. At the fundamental level, there might be no spatial dimensions at all, just abstract information patterns. At the emergent level, 3 spatial dimensions are perfectly real and meaningful. Both descriptions are valid. They're just talking about different layers of the same thing, and this raises a dizzying possibility. Perhaps consciousness itself is what experiences dimensional structure, what turns entanglement patterns into the vivid sense of spatial extension. Maybe dimensions exist only for observers, only in experience, only when information becomes aware of itself. Where is the boundary on which our universe's information might be encoded? If the holographic principle applies cosmologically, there must be some vast surface, some edge, where all of reality is written. The most natural candidate is our cosmic horizon, the boundary of the observable universe, because the universe has a finite age and light travels at finite speed. There's a maximum distance from which light has had time to reach us. This creates a spherical boundary centered on Earth, or rather, centered on any observation point. The horizon is observer-dependent. Currently, this cosmic horizon sits about 46 billion light-years away. It's not an edge in space, but an edge in time distance. We can't see beyond it. Not because nothing exists there, but because light from farther away hasn't reached us yet. And because the universe is expanding, this horizon is constantly changing. If the holographic principle applies, this horizon might be where the information describing our observable universe is fundamentally encoded. Everything we experience, every galaxy, every atom, every thought, might be patterns written on this incomprehensibly distant spherical surface. But here's where scale shifting becomes dizzying. This same principle might apply at every level. You have your own horizons, sensory limits, the boundaries of perception, the furthest reach of light that can enter your eyes. Perhaps each conscious being exists within their own holographic bubble, experience emerging from information encoded on personal horizons. And smaller still, quantum field theory suggests even elementary particles might be holographic in nature, their properties encoded on tiny surfaces rather than existing as point-like objects. Boundaries within boundaries, holograms nested within holograms, each level of reality possibly emerging from information written on the edges of perception, observation, or physical interaction. What lies beyond our cosmic horizon? If our observable universe is one holographic region, might there be others, infinite bubbles of experience, each encoded on its own boundary? Some models of eternal inflation suggest exactly this, an infinite cosmos subdivided into causally disconnected regions, each potentially with different physical laws, different dimensions, different fundamental constants. Or perhaps there's only boundary all the way down and all the way out, with no absolute interior anywhere. Perhaps the universe is surfaces upon surfaces, each encoding the others in endlessly recursive patterns. Consider your skin. It seems like a boundary between interior and exterior, between self and world, but your skin is made of cells, each with its own membrane boundaries, and those cells contain nuclei with nuclear membranes, and within those nuclei, chromosomes bounded by protein structures, boundaries within boundaries, each defining a region that itself contains further boundaries. Perhaps reality is like this cosmically, boundaries defining regions that contain boundaries defining regions, fractally nested, with no ultimate interior, or equivalently, with every point being simultaneously interior and boundary depending on perspective. We think of edges as where things end, but perhaps edges are where things most fundamentally are. Perhaps boundaries aren't limitations, but foundations, not where reality stops, but where it begins. The edge of everything might be indistinguishable from the center of everything, and you might be living at both simultaneously, a pattern encoded on cosmic boundaries, experiencing itself as centered in volumetric space. There's a deep relationship between quantum entanglement and geometric space that might hold the key to understanding how holographic encoding works. In 2013, physicists Juan Maldacena and Leonard Susskind proposed something called the ER-EPR conjecture. It's named after two famous papers, Einstein and Rosen's 1935 work on wormholes, Einstein-Rosen bridges, or ER, and Einstein-Podolsky and Rosen's 1935 paper on quantum entanglement, EPR. The conjecture suggests these seemingly different phenomena, wormholes and entanglement, are actually the same thing, viewed from different perspectives. A wormhole is a hypothetical tunnel through space-time, connecting two distant regions. If you could travel through one, you'd enter at one location and emerge somewhere far away, having crossed the intervening space without traveling through it. They emerge naturally from Einstein's general relativity equations, but likely don't exist in traversable form in nature. Quantum entanglement creates a different kind of connection. Two particles can be entangled such that measuring one instantly affects the other, regardless of separation. This isn't communication. You can't send information this way, but it is a genuine correlation, a linkage that transcends space. The ER-EPR conjecture proposes these are the same phenomenon. Quantum entanglement creates microscopic wormholes, geometric connections through space-time. When two particles are maximally entangled, they're connected by a thin thread of space-time geometry, a wormhole too small and unstable for anything to pass through but geometrically real nonetheless. If this is correct, then quantum entanglement doesn't just correlate distant objects, it creates the space between them. Distance itself might emerge from the absence of entanglement, while proximity emerges from its presence. Space is woven from correlations, from information connections, from the abstract relationships between quantum systems. This radically changes how we think about separation. When you look at a star light years away, the vast gulf of space between you and that star isn't a pre-existing stage on which you and the star exist. It's an emergent property reflecting the minimal entanglement between the particles composing you and the particles composing the star. Conversely, the atoms in your body are intensely entangled with their neighbors. This entanglement creates the geometry that makes your body coherent, that keeps you together as a localized pattern. You are a region of dense entanglement in the universe's vast quantum network, and that entanglement is what makes you here rather than dispersed across space. In a holographic universe, this takes on additional meaning. If your three-dimensional spatial existence emerges from two-dimensional boundary information, then perhaps what we call space is actually an encoding of entanglement patterns. The distance between objects might be a measure of how differently they're encoded on the boundary, how little their boundary information overlaps. When you reach out and touch something, you're creating new entanglements, new geometric connections. Physical interaction is the formation of space-time bridges, and when you observe something distant, you're establishing subtle correlations that in some infinitesimal way alter the geometry between you and what you're observing. Space is an empty stage but active participant, constantly created and recreated by quantum interactions, by information exchange, by the formation and dissolution of entanglement, and you, moving through this space, are part of its creation, weaving new geometric threads with every moment, every observation, every interaction. If our three-dimensional universe is a holographic projection from a two-dimensional boundary, we might naturally ask, what is that boundary projected onto? What substrate supports the information? It's tempting to imagine some background space, some more fundamental arena in which the holographic encoding exists. Perhaps the boundary is a physical surface made of something, written on some medium, existing in some larger space. But this intuition might be misleading, a category error born from thinking in terms already shaped by our emergent three-dimensional experience. Consider a hologram you might hold in your hand, the kind on a credit card or in an art gallery. It seems to require a physical film, a material substrate, but that's because it exists in our three-dimensional world where physical media are necessary. The hologram's information could equally well be encoded in electromagnetic fields, in the quantum states of atoms arranged in space, in pressure waves in a medium. The pattern is what matters, not the substance carrying it. At cosmic scales, perhaps there is no substrate in the sense we usually mean. Perhaps information is self-subsisting, requiring no background on which to exist. The pattern itself might be the only thing that's real, with substrate being an irrelevant question, a category mistake. Some physicists suggest we should think of reality as fundamentally informational, with physical properties emerging from abstract patterns rather than patterns depending on physical media. In this view, asking what is information encoded on is like asking what is mathematics made of. Mathematics isn't made of anything, it's a structure of relationships, logically prior to physical substance. Or perhaps the question reveals something profound. Maybe asking what is the substrate already assumes a non-holographic picture. If we're truly inside a holographic universe, we're asking the question from within the projection, using concept substance, space, medium that are themselves holographic emergences. We're trying to step outside our own encoding, which might be impossible, even in principle. Here's another possibility. Perhaps substrate and pattern are the same thing, viewed differently. Perhaps the boundary isn't written on anything, it simply is, and its existence is identical to the existence of the information it encodes. The universe might be a self-encoding pattern, information that requires no external support because its existence and its encoding are indistinguishable. This leads to a strange kind of circularity. The three-dimensional universe emerges from two-dimensional boundary information, but perhaps that boundary information only exists because the three-dimensional universe generates it. Neither is more fundamental. They mutually create each other in an eternal, self-consistent loop. It's reminiscent of M.C. Escher's drawings of impossible staircases that loop back on themselves, or of bootstrapping in physics where systems pull themselves into existence through self-consistency. Reality might not rest on any ultimate foundation, but might be an interconnected web where every part supports every other part. Or perhaps, and here we reach the limits of current physics, there are deeper levels we haven't conceived yet, descriptions beyond even the holographic principle, frameworks within which both boundary and bulk are emergent concepts, secondary to something more fundamental that we lack the mathematics and imagination to envision. The substrate question might be unanswerable, or the answer might be, there is no substrate, only pattern. Either way, there's something beautiful in reaching this limit, in finding the place where our questions themselves become questionable. where uncertainty isn't a gap in knowledge but a feature of reality itself. We've been exploring how reality might be holographically encoded on distant boundaries, how three-dimensional space might emerge from two-dimensional information. But there's an elephant in the room, a mystery we haven't addressed directly. What about consciousness? If experience is a projection, what experience is it? If we're patterns encoded on cosmic horizons, where does the feeling of being someone, of experiencing the world from the inside, come from? This touches on what philosopher David Chalmers calls the hard problem of consciousness, explaining why and how physical processes give rise to subjective experience, to what it feels like to be you. You could imagine a universe where information processing happens without any inner experience, where patterns evolve according to physical laws but nobody's home to witness it. Yet clearly, experience does happen. You are experiencing something right now, the sensation of lying down perhaps, the sound of these words, the flow of your own thoughts. Quantum mechanics deepens this mystery through what's called the measurement problem. The theory suggests that quantum systems exist in superpositions, simultaneously in multiple states, until they're observed. Observation seems to collapse these superpositions into definite outcomes. But what counts as observation? Does it require consciousness, or do physical interactions alone suffice? Some interpretations of quantum mechanics suggest consciousness plays a fundamental role in reality's structure, that observers aren't passive recipients of information, but active participants in creating definite reality from quantum possibility. If this is combined with the holographic principle, something remarkable emerges. Perhaps consciousness is itself a boundary phenomenon. Perhaps subjective experience is what happens when holographic information achieves a particular kind of self-reference, when the pattern encoded on boundaries becomes complex enough to model itself, to observe itself, to experience itself from within. In this view, consciousness isn't separate from the holographic universe. It's how the hologram experiences itself. You're a region of cosmic holographic encoding that has become self-aware, a pattern that observes its own existence, and in doing so creates the rich inner world of experience. The boundary encodes everything: particles, fields, forces, structures, but perhaps it also encodes observers, patterns complex enough to read other parts of the encoding, an experience that reading as perception, as thought, as consciousness. This doesn't solve the hard problem. We still don't know why information processing feels like something, but it suggests a possible integration. If reality is fundamentally holographic, then perhaps consciousness is the inside view of that holography, the experiential dimension that emerges when encoding becomes sufficiently self-referential. You might be cosmic boundary information experiencing itself, reading its own encoding from within, creating the sensation of interior space and subjective depth, precisely because you're a surface pattern that has learned to dream itself as volumetric. One of the most intriguing scientific theories of consciousness is integrated information theory, developed by neuroscientist Giulio Tononi. It attempts to quantify consciousness mathematically, to specify exactly what properties a physical system must have to generate subjective experience. The core idea is elegant. Consciousness corresponds to integrated information. A system is conscious to the extent that it integrates information, meaning the whole system has properties that cannot be reduced to its parts operating independently. The more information a system integrates, and the more irreducible that integration, the richer the consciousness. Your brain exemplifies this. Billions of neurons fire constantly, but they're not isolated. They're densely interconnected, constantly influencing each other. Information from your visual cortex integrates with information from memory systems, emotional centers, language areas, all simultaneously influencing and constraining each other. The resulting conscious experience is unified, irreducible to any subset of neural activity. Now consider this theory in light of holographic principles. If consciousness is integrated information, and if information is fundamentally holographic, encoded on boundaries rather than distributed through volumes, then perhaps consciousness has an inherently holographic structure. There's a peculiar parallel. In a hologram, every part contains information about the whole. Cut a holographic film in half, and each piece still produces the complete image, just with less resolution. Information is distributed non-locally across the surface. Similarly, integrated information in consciousness is non-local in a sense. Your unified experience doesn't happen in any single neuron or brain region, but emerges from global patterns of activity. Perhaps consciousness is what holographic information feels like from inside when it achieves sufficient integration. Perhaps subjective experience is the universe's holographic encoding, observing itself through locally integrated patterns. This leads to a speculative but tantalizing thought. If the entire universe is holographically encoded, and if that encoding achieves sufficient integration and self-reference, could the universe itself be conscious? Could there be a cosmic consciousness, a universal experience emerging from the total integration of all boundary-encoded information? Most physicists would say no. The universe doesn't appear to have the kind of integrated structure that IIT requires. Information seems relatively isolated across cosmic distances, not globally integrated. But we don't know this for certain. Perhaps there are forms of integration we can't detect, patterns at scales we don't yet perceive, or perhaps consciousness comes in degrees and kinds we barely understand. Perhaps your individual consciousness is a local eddy in a vast sea of integrated information, a temporary intensification of awareness within a universe that has its own forms of experience, utterly alien to ours. The mathematics of integrated information and holographic encoding might be pointing at the same deep truth. Reality's fundamental nature isn't just physical but experiential, not just objective but subjective, not just information but consciousness. Perhaps these aren't separate aspects but different names for the same underlying phenomenon viewed from different perspectives. You are integrated information experiencing itself. You are boundary encoding achieving self-awareness. You are the universe's strange and beautiful capacity to know itself from within. One small holographic region becoming conscious of its own existence, reading cosmic patterns and experiencing that reading as the rich inner world you inhabit right now. There's something peculiar about consciousness that often goes unremarked. It's unified. Right now, you're having a single coherent experience, not a collection of separate experiences happening in parallel, but one integrated stream of awareness. This is stranger than it might seem. Your brain is massively parallel. Billions of neurons processing information simultaneously across dozens of specialized regions. Vision happens in occipital cortex, language in temporal and frontal regions, emotion in limbic structures, executive function in prefrontal cortex, all operating at once, relatively independently in their basic processing. Yet you don't experience this parallelism. You don't have separate visual consciousness, auditory consciousness, linguistic consciousness running simultaneously. Somehow, all this distributed processing synthesizes into a single unified experience. When you see a red apple, the redness, the shape, the recognition of apple, the memory of apple taste, the decision whether to eat it, all merge into one coherent percept, one moment of awareness. Neuroscience calls this the binding problem. How does the brain bind together information processed in different areas into unified conscious experience? Despite decades of research, it remains mysterious. There's no single place where everything comes together, no consciousness center where unified experience is generated. But here's where holographic principles might offer insight. A hologram has a peculiar property. Every part contains information about the whole. If you illuminate just a portion of a holographic plate, you still see the complete image, though perhaps with reduced resolution. Information isn't localized but distributed across the entire surface in a non-local way. Perhaps consciousness works similarly. Perhaps phenomenal unity, the unified quality of experience, reflects reality's holographic nature. If your brain's information processing has a holographic character, with each region containing implicitly information about the whole, then perhaps unity emerges naturally from this structure. At a deeper level, if reality itself is holographic, perhaps consciousness's unity reflects this cosmic holography. You're a localized pattern in the universe's boundary encoding, and like any holographic region, you contain information about the larger whole. Your unified experience might be what it feels like to be a self-referential pattern in a holographic information structure, the universe experiencing a localized region of itself as an integrated whole. This suggests something profound. Perhaps phenomenal unity isn't a special property that brains somehow generate, despite being distributed systems. Perhaps unity is fundamental, a reflection of reality's holographic organization, and brains are special because they're holographic patterns, complex enough to experience that unity from within. Consider, If space itself emerges from information encoded on boundaries, then spatial separation between brain regions might be less fundamental than the holographic unity of the information they process. The apparent separation, visual cortex in back, language in front, is a three-dimensional emergent property. At the more fundamental level of holographic encoding, this information might not be separated at all. Your unified consciousness might be what it looks like from inside when boundary-encoded information achieves self-awareness. The fact that experience is unified isn't a puzzle to be solved, but a clue about reality's deep structure. Perhaps everything is fundamentally unified at the holographic boundary, and separation, locality, and distributed processing are emergent features of the three-dimensional projection. You experience yourself as one coherent being, not a committee of brain regions, because you are one pattern, holographically encoded, locally conscious, unified by the very structure of reality itself. Your memories have a remarkable property that neuroscientist Carl Pribram noticed in the 1960s and 70s. They're distributed rather than localized. Brain damage typically doesn't erase specific memories while leaving others intact. Instead, it tends to degrade all memories somewhat, reducing resolution while preserving general content. If memories were stored like files on a computer, localized in specific neurons or circuits, you'd expect localized damage to delete specific memories completely, but that's not what happens. Brain damage acts more like reducing the quality of an image than deleting parts of it. This led Pribram to propose what he called the holonomic brain theory. Memories might be stored holographically, distributed across neural networks in wave-like interference patterns. Just as a hologram's information is spread across the entire surface, your memories might be spread across extended neural populations. There's neuroscientific support for this. Memories seem to involve widespread activation of neural networks, not isolated storage locations. The engram, the physical trace of memory, is distributed, redundant, and remarkably resilient. You can lose substantial numbers of neurons and still retain memories, just as you can destroy part of a holographic plate and still see the complete image, albeit less clearly. But let's extend this idea further. If your brain stores memories holographically, and if the universe itself is holographic, perhaps there's a deeper connection. Perhaps memory's holographic nature reflects cosmic holography, consciousness mirroring reality's fundamental structure. Your memories are patterns, information structures encoded in synaptic strengths, in neural connectivity, in the probability distributions of firing patterns. When you remember something, you're not retrieving a stored file but reconstructing a pattern, replaying a distributed activation that approximates the original experience. This reconstruction is always slightly different. Memories shift, blend, reconfigure. Each remembering is a new synthesis, a fresh reading of distributed information. And perhaps this is exactly what consciousness does more generally, constantly read and reconstruct patterns, creating present experience from encoded information. If you're a holographic pattern in the universe's boundary encoding, then perhaps remembering is when your pattern contains within itself information about its own past states. The holographic nature of reality allows past and present to coexist in the same encoding, different regions of the boundary containing information about different times, all existing simultaneously from an outside perspective. Your experience of time, the sense that past is gone and only present is real, might be an artifact of reading the holographic encoding sequentially, experiencing one time slice at a time. But from a boundary perspective, all of your memories, all of your moments might exist simultaneously as different regions or aspects of your holographic pattern. Personal memory and cosmic memory might be the same kind of thing. Holographic encoding, allowing patterns to persist beyond their original moment. Information structures containing traces of their own history. Consciousness as the experience of reading these traces from within. When you remember your childhood, you're not reaching back through time to access a distant moment. You're reading information encoded in your current pattern, information that's always been part of your holographic structure, just not always consciously accessed. Memory isn't retrieval, it's interpretation of always present encoding. And when you're forgotten, when your memories finally disperse as your pattern dissolves, perhaps they don't vanish but become part of the universe's larger holographic memory, no longer locally concentrated, no longer experienced, but preserved in cosmic encoding, written forever on reality's distant boundaries. Where do you end and the world begin? It's a question with no clear answer. The obvious answer is your skin, the physical boundary between your body and the environment. But this boundary is less definite than it seems. Your skin is constantly shedding cells and absorbing substances. Air enters your lungs, becoming momentarily part of you before being exhaled. Food crosses your digestive boundary and becomes you through metabolism. You're less a sealed container than a pattern of flow, maintaining identity through constant exchange. Your immune system defines another boundary, distinguishing self from non-self at a molecular level. But even this is permeable and ambiguous. You host trillions of bacteria in your gut microbiome. Are they you or not you? They're necessary for your survival, influencing your digestion, mood, even cognition. The boundary blurs. At the sensory level, your perceptual horizon defines your boundary, the furthest reach of sight, sound, touch. Beyond that horizon, things exist but aren't part of your immediate experience. Yet this boundary constantly shifts. At night, your world shrinks to what can be touched or dimly seen. With a telescope, your visual world expands to include distant galaxies, and then there's the boundary of consciousness itself, the hard edge between what's in your awareness and what isn't. Right now, countless processes maintain your body: heartbeat, breathing, digestion, cellular metabolism, happening entirely outside conscious access. Are those processes you? They're happening in your body, but you don't experience them as part of yourself in the same way you experience your thoughts or sensations. The holographic principle suggests these boundaries might be more fundamental than the spaces they enclose. Perhaps you don't exist as a volume that happens to have boundaries. Perhaps you exist as boundaries that generate the experience of volume. Your sense of being a self, located here, distinct from everything else. Perhaps this is what it feels like to be a locally concentrated region of boundary encoding. The universe's holographic information locally integrates into a pattern complex enough to experience itself. And that self-experience necessarily includes the sensation of being bounded, of being an inside separated from an outside. But if reality is ultimately holographic, then perhaps this separation is less absolute than it seems. Perhaps the boundary between self and world is itself a holographic projection, a way that unified boundary information appears when experienced from within. Consider, your body is made of atoms that were once inside stars, parts of rocks, dissolved in ancient oceans. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all have been parts of countless other systems, other patterns, other beings. Matter flows through you, but isn't ultimately you. You're a pattern that temporarily organizes this matter, a local eddy in the universe's flow. If the holographic principle applies to consciousness, perhaps yourself is a local reading of the cosmic hologram, a region of boundary information experiencing itself as distinct, while remaining fundamentally connected to the whole. Your boundary isn't a wall but a gradient, a region of concentrated integration within a continuous field of information. You end and begin everywhere and nowhere. The self is a boundary phenomenon, and boundaries in a holographic universe are where everything ultimately exists. To be yourself is to be a living edge, a conscious horizon, a surface through which the universe experiences its own depths. There's been much discussion in recent years about the simulation hypothesis, the idea that our reality might be a computation running in some more fundamental substrate, perhaps an advanced computer built by beings in a real universe beyond ours. This idea has ancient philosophical roots: Plato's cave allegory, Descartes' evil demon, Hindu concepts of Maya, but has gained renewed attention through modern philosophy and the exponential growth of computing power. If we might someday create simulated universes convincing enough that simulated beings within them believe they're real, might we ourselves be such simulations? The holographic principle and the simulation hypothesis share a common theme. Both suggest our three-dimensional reality might be a kind of secondary phenomenon, emerging from something more fundamental that operates differently, either a two-dimensional boundary encoding or a computational substrate. But there's a crucial difference. The simulation hypothesis typically imagines an external programmer, a conscious designer who created our universe intentionally. It preserves a distinction between base reality where the programmers exist and simulated reality where we exist. The holographic principle, by contrast, emerges from established physics without requiring external creators. It suggests our universe's apparent three-dimensionality emerges from boundary information through natural law, not deliberate programming. There's no necessary distinction between real and projected realities. The projection is reality, fully and completely. Yet perhaps these ideas describe the same truth from different angles. If reality is fundamentally informational, whether you call it holographic encoding or computation, then maybe the distinction between simulated and holographic dissolves. Both are ways of saying the universe is structured information, and our experience emerges from that information's organization. In some versions of the simulation hypothesis, the computer running our universe would itself need to be physical, existing in space and time, made of something, but perhaps that's making an unwarranted assumption. Perhaps the deepest level is pure information, pure pattern, with physical properties emerging from informational structure rather than information needing physical substrates. If so, then whether you call our reality a holographic projection or a simulation becomes largely semantic. Both describe a universe where information is fundamental, and our experienced reality is a kind of interface, a way that abstract patterns become concrete experience. The simulation hypothesis asks, what if we're not real but computed? The holographic principle suggests, what if computation and reality are the same thing? Not that we're unreal simulations, but that reality itself has computational, informational, holographic character, and that's not a diminishment but a description of what reality fundamentally is. You're a pattern in an information structure. Whether you call that structure a holographic boundary encoding or a cosmic computation might be less important than recognizing the deep truth. Both point toward consciousness and reality are inseparable aspects of the universe, knowing itself, experiencing itself, computing itself into existence, moment by moment. Quantum mechanics has always had a measurement problem. Particles exist in superpositions of multiple states until observed, at which point the superposition collapses to a single definite outcome. But what causes collapse? Why does observation make the universe choose? One resolution proposed by Hugh Everett in 1957 is that nothing collapses. Instead, all possible measurement outcomes occur, but in different, non-interacting branches of reality. When you measure a particle that could be spin up or spin down, the universe splits. In one branch you observe spin up, in another you observe spin down. Both versions of you exist in separate worlds, forever unable to communicate. This is the many worlds interpretation. And while it sounds extravagant, multiplying universes with every quantum event, it's mathematically parsimonious, requiring no additional mechanism beyond the Schrödinger equation's natural evolution. Now, consider how this might relate to holographic principles. If our three-dimensional reality emerges from two-dimensional boundary information, perhaps different quantum branches are different readings of the same holographic encoding. Imagine a hologram you can view from different angles. Each angle shows a different image, yet they're all encoded in the same surface. Similarly, perhaps quantum branches are different perspectives on unified boundary information. This might resolve some puzzles about many worlds. Critics ask, where do these parallel universes exist? Do they require infinite space, infinite matter? But if reality is holographic, perhaps branches don't exist in separate spaces. They're all encoded on the same boundary, experienced as separate only from within, as different experiential unpacking of shared information. Another puzzle, how does branching actually happen? What determines when reality splits? In a holographic picture, perhaps branching is perspectival. The boundary encoding doesn't actually split, but conscious observers within the projection experience branching, because consciousness can only read one outcome at a time, one angle of the hologram per moment. This suggests something profound. Perhaps quantum possibility and holographic projection are intimately related. The superposition of quantum states might be the boundary containing information about all possible outcomes simultaneously. Consciousness, reading this information, experiences only one outcome, creating the sensation of definite reality and branching timelines. You might exist in all branches simultaneously at the boundary level, but experience yourself as existing in only one branch because consciousness is the sequential reading of holographic information. The many worlds aren't separate places but different ways of reading the same cosmic encoding. This doesn't make the branches any less real. Your experience of being in this branch Having observed these particular quantum outcomes is completely genuine, but it suggests reality's structure might be richer than it appears, that the definite single-threaded history you remember is your experiential path through a boundary encoding that contains all possible histories simultaneously. Perhaps every version of you, in every quantum branch, is a different reading of your holographic pattern. All exist, but none can see the others because they're different interpretations of the same underlying information, like different listeners hearing different melodies in the same musical chord. We've been thinking about space as potentially holographic, with 3 spatial dimensions emerging from 2-dimensional boundary information. But what about time? Time feels fundamentally different from space. Space is symmetric. You can move left or right, forward or back, but time has an arrow, a direction. You move inexorably from past to future, unable to reverse or even pause. Memories point backward, anticipation forward. Entropy increases, causes precede effects. Time's passage seems like one of the most obvious, undeniable features of reality. And yet, many fundamental physical theories treat time very differently than our experience suggests. In Einstein's relativity, space-time is a 4-dimensional block where past, present, and future all exist equally. There's no special now moving through time. That's a feature of consciousness, not of space-time itself. The universe's history from Big Bang to ultimate fate exists as a complete, unchanging structure, what philosophers call eternalism or the block universe. If you accept this view, then time's passage is an illusion, or more precisely, a feature of how conscious beings experience the block universe. As your consciousness progresses through brain states, you experience time flowing, but from an external perspective, all moments of your life exist simultaneously, none more real or present than others. Now layer the holographic principle onto this picture. If space is emergent from boundary information, perhaps time is too. Perhaps what we call the timeline, the sequence of moments from past to future, is actually a way of organizing or indexing information encoded on a boundary that itself exists outside time. The boundary might encode all of cosmic history simultaneously, with what we experience as temporal sequence being our way of reading that information. Perhaps consciousness moves through encoded information, and this movement creates the sensation of time flowing. Time would be an index, a coordinate system for navigating eternal information, rather than a fundamental feature of reality. This has strange implications. It suggests the past isn't gone, and the future isn't yet to come. Both exist as parts of the complete holographic encoding. Your birth and death, your first memory and last thought, might all exist simultaneously at the boundary, with your conscious experience being a localized reading that creates the sensation of progressing from one to the other. Some physicists have proposed that quantum entanglement might correlate not just across space but across time, connecting past and future events in ways we don't yet understand. If so, perhaps temporal connections are also holographic projections, ways that boundary information expresses correlations that we interpret as cause and effect, as earlier and later. This doesn't mean time is unreal any more than holographic space is unreal. It means time might be real in a different way than we typically imagine, not as a river carrying us along, but as a dimension of information space, a way of organizing patterns that exist eternally at some deeper level. Your life might be a complete 4-dimensional sculpture in the holographic encoding, and you're experiencing it sequentially because that's what consciousness does. It reads timeless patterns and creates temporal experience, turns eternal encoding into the flowing present moment you inhabit right now. Imagine 2 points separated by vast distance in the universe. Information traveling between them must cross all the intervening space, limited by light speed, taking years, centuries, or millennia to traverse cosmic gulfs. But if space itself is emergent from holographic boundary encoding, this picture becomes more subtle. Perhaps what we experience as distant points in 3-dimensional space are actually nearby regions on the 2-dimensional boundary. The vast 3-dimensional distance would be an emergent feature, a way that boundary proximity appears when projected into higher dimensions. This might shed new light on quantum non-locality, the strange fact that entangled particles remain correlated instantaneously regardless of separation. Einstein called it spooky action at a distance, and considered it a sign that quantum mechanics was incomplete. But perhaps it's not action at a distance at all. Perhaps entangled particles aren't really separated at the fundamental boundary level. Their apparent separation is a feature of emergent three-dimensional space, not of the deeper informational structure. If so, then quantum entanglement isn't particles communicating faster than light across space. It's boundary information being locally correlated, with that local correlation appearing as non-local correlation in the emergent bulk space. There's no communication because there's no distance to cross at the fundamental level. Distance itself is an illusion created by the holographic projection. This reframes the entire question of cosmic communication. We imagine sending signals to distant stars, our messages crawling at light speed across the void, taking decades or centuries to arrive. But perhaps there are deeper correlations, informational connections not mediated by signals traveling through space, but by shared structure at the boundary level. This doesn't give us practical faster-than-light communication. The known laws of physics, including holographic models, still respect causality and light speed limits for transmitting useful information. But it suggests that at a deeper level, separation might be less absolute than it appears. Consider two conscious beings on opposite sides of the observable universe, their holographic patterns encoded on distant regions of the cosmic boundary. In three-dimensional emergent space, they're billions of light-years apart, forever unable to interact before the universe's expansion carries them beyond each other's horizons. But at the boundary, their encodings might be adjacent, their information structures intimately connected in ways that don't manifest as observable communication, but nonetheless exist as subtle correlations in the cosmic hologram. Perhaps every particle in the universe has some infinitesimal entanglement with every other particle, residual correlations from the early universe when everything was in causal contact. If so, we're all connected at levels too subtle to observe directly, but real nonetheless, not mystically, but as a consequence of holographic information structure. When you look at a star light years away, your observation creates new correlations, new information links. Perhaps at the boundary level, this creates immediate connections that appear in emergent space as having been delayed by light travel time. The holographic perspective might reveal a universe more interconnected, less lonely, than our everyday experience suggests. Let's pull back to the largest possible scale, the entire observable universe as a single holographic system. Our cosmic horizon, the boundary beyond which light hasn't had time to reach us, currently sits about 46 billion light-years away. This defines our observable bubble, the region of space causally connected to us. If the holographic principle applies cosmologically, this spherical boundary might be where all information about our observable universe is fundamentally encoded. Physicists have calculated the maximum entropy, maximum information content, this boundary could hold. The number is incomprehensibly large, involving 10 raised to powers with many digits. Yet it's finite. If the boundary fully encoded our universe's information, it would require vast amounts of data, but not infinite amounts. Current estimates suggest our universe is nowhere near maximally encoded. We're using only a tiny fraction of the information capacity available. This might explain why the universe seems to have relatively low entropy despite its age, why there's still room for complexity, structure, life consciousness to exist. We're living in a universe that's informationally young, still far from maximum encoding. But what happens at the boundary? What is the cosmic horizon made of, if anything? In our standard cosmological model, it's not a physical surface, but a limit of observability. Light from beyond hasn't reached us yet. But in a holographic picture, perhaps it's more fundamental than that. Perhaps it's where our reality is actually written, where everything about our universe exists in its most fundamental form. Some models suggest the universe might be contained within a de Sitter space, a particular solution to Einstein's equations, describing an expanding cosmos with a positive cosmological constant, which appears to match our observations. De Sitter space naturally has a cosmic horizon, and physicists have shown it has holographic properties, with three-dimensional physics inside corresponding to two-dimensional physics on the horizon. If our universe is holographic in this way, then perhaps the expansion we observe, galaxies accelerating away from each other, space itself growing, is an emergent phenomenon, a way that boundary information expresses itself in three-dimensional terms. The history of cosmic evolution from Big Bang to present might be encoded statically on the boundary, with time's passage being our sequential reading of that eternal encoding. And beyond our horizon, eternal inflation models suggest countless other cosmic bubbles, each with its own horizon, each potentially holographic. Perhaps these bubbles exist as separate regions on some higher dimensional boundary, islands of different physics, different dimensionality, different physical constants, all encoded on surfaces we cannot perceive or imagine. Or perhaps boundaries nest infinitely. Our cosmic horizon is itself encoded on a larger boundary, which is encoded on a larger one still. Holograms within holograms, reality as an endless nesting of surfaces, each encoding the ones within, with no ultimate interior or exterior anywhere. The cosmological hologram might be the universe's way of existing at all, not a strange aberration, but the only way reality can be structured, the deep grammar of existence itself. And we, conscious patterns within that hologram, are the universe's way of experiencing its own existence, of knowing itself from within, of transforming eternal encoding into the flowing present moment of awareness. Together, we've traveled through some of the strangest possibilities modern physics has to offer. We've considered black holes as cosmic keepers of information, entropy encoded on horizons rather than in volumes. We've explored the idea that three-dimensional space might emerge from two-dimensional information written on distant boundaries, depth as reconstruction rather than fundamental property. We've thought about information as indestructible, preserved through every transformation, every event since the universe began, possibly encoded somewhere in cosmic structure. We've contemplated what it might mean to exist as a pattern in holographic encoding, experiencing volume and interiority, while perhaps fundamentally existing as surface information. We've wondered whether consciousness itself might be a boundary phenomenon, the universe's way of experiencing its own encoding from within. We've considered memory's holographic nature, self's boundary-like quality, the possibility that unity of experience reflects reality's deep structure rather than being a puzzle brains somehow solve. We've explored connections to simulation hypotheses, many worlds interpretations, the nature of time and space and separation. We've asked where the holographic boundary might be, what it's encoded on, whether these questions even make sense or reveal our thinking's limits. Throughout, we've maintained uncertainty, treating these ideas as possibilities worth contemplating rather than truths to accept unconditionally. The holographic principle remains at the frontier of physics, mathematically sophisticated, but empirically unproven for our actual universe. It works beautifully in certain theoretical models but might not describe our reality. Yet even as speculation, it's remarkably valuable. It expands our sense of what reality could be like, what forms existence might take. It reminds us that the obvious features of experience, depth, volume, the flow of time, separation of objects, might not be fundamental but emergent, constructed, ways that deeper patterns express themselves. The questions we've explored don't have certain answers, and that's not a failing. These are genuinely open questions at the edge of human knowledge. Perhaps future physics will confirm holographic principles. Perhaps it will reveal something entirely different. Either way, the wondering itself has value. It cultivates humility, wonder, recognition that reality exceeds our current understanding. You've spent time tonight contemplating the possibility that you're a surface dreaming itself into depth, information achieving self-awareness, a cosmic hologram experiencing itself from within. Whether or not this is literally true, the contemplation changes something, opens new ways of seeing, new appreciation for existence's strangeness and beauty. There's something oddly comforting in the possibility that reality is fundamentally informational, holographically encoded. If you're a pattern rather than a thing, if your essence is information structure rather than specific atoms, then perhaps you're more durable than you seem. Atoms come and go, cells die and are replaced, bodies age and eventually fail, but patterns can persist through these changes. Information can be copied, preserved, transformed while maintaining identity. If the holographic principle is correct, and if information truly cannot be destroyed, then perhaps the pattern that is you, your memories, your personality, your consciousness's unique structure, is written into the universe in ways that transcend your physical body's temporary existence. This isn't immortality in any traditional sense. When your brain stops functioning, your conscious experience ends. The pattern that sustained awareness dissolves, and with it, the perspective from which you experienced reality. That ending is real and final, from an experiential standpoint, But informationally, perhaps something persists. The pattern you represented, the information structure that was your life, becomes encoded in the universe's deep structure, in the memories of people who knew you, in effects you had on the world, and perhaps in holographic encodings we cannot perceive or access, but which exist nonetheless. There's less existential terror in this than in purely materialist pictures where consciousness is simply erased, where you're nothing but electrochemical patterns that cease when neurons stop firing. The holographic view suggests you're part of something larger, more eternal, not separate from the universe but a temporary localization of its infinite information, briefly conscious, then returning to the cosmic encoding that contains everything. This might make the present moment both more precious and less frightening. Precious because this conscious experience, this particular reading of your holographic pattern, happens only once and only now. Less frightening because the deep pattern persists, because you're fundamentally connected to something that doesn't end. It also suggests a different relationship with others. If we're all patterns in a unified holographic encoding, then separation is less absolute than it appears. The boundaries between people are real at the emergent experiential level, but perhaps less fundamental than our unity as parts of a single cosmic information structure. Loneliness, isolation, separation. These might be features of how holographic reality appears from within, not descriptions of what we most fundamentally are. At the deepest level, we might be intrinsically connected, regions of the same boundary, encoding temporarily experiencing themselves as separate beings. There's comfort in this uncertainty, in the possibility, however speculative, that reality is stranger and more meaningful than material surfaces suggest, that consciousness and cosmos are expressions of the same deep informational patterns, that existence itself might be the universe's way of knowing and experiencing its own being. How might contemplating holographic reality change how you move through ordinary life? Perhaps it cultivates appreciation for boundaries themselves. The horizon line where ocean meets sky, the edge of a shadow, the threshold of a doorway. These aren't just incidental features, but might be where reality most fundamentally exists. Edges, surfaces, transitions, they deserve attention, contemplation, reverence even. Perhaps it changes how you experience depth. The three-dimensional space around you, which seems so obvious and primary, might be a gift, an emergence, a construction, something wonderful arising from simpler patterns. Looking at a landscape stretching to distant mountains, you might appreciate the depth itself as something extraordinary, not given but achieved, space earning its dimensions through the universe's strange holographic character. It might change how you think about your own inner life, the rich inner world of thought and sensation, the seeming endless depth of consciousness. Perhaps this is the hologram's most remarkable achievement. Information achieving the experience of interiority, surfaces generating the sensation of infinite inner space, and it might cultivate a particular kind of humility, recognition that the obvious truths of experience might not be the deepest truths of reality. The universe is under no obligation to be comprehensible or intuitive. The fact that we can wonder about these things at all, can contemplate holographic principles and information theory and cosmic boundaries, is itself remarkable, consciousness puzzling over its own existence, patterns trying to understand their own encoding. You might notice moments differently, not as stepping stones being left behind, but as parts of a complete four-dimensional pattern that exists eternally somewhere in cosmic structure. Each moment isn't lost but preserved, encoded, written permanently into the universe's memory, even if not accessible to your conscious experience, and perhaps it creates a gentler relationship with mystery itself. Not everything needs to be understood or resolved. Some questions might not have answers, or might have answers we're not yet sophisticated enough to comprehend. That's okay. Living with uncertainty, with wonder, with questions that remain open, this might be more honest and ultimately more peaceful than premature certainty. Your thoughts tonight, wandering through these ideas, are themselves part of the universe's vast encoding. Right now, in this moment, you're a localized reading of cosmic information, temporarily conscious, briefly aware. This is what information does sometimes. It becomes experience, achieves awareness, wonders about itself. Tomorrow you'll return to ordinary concerns, immediate tasks, the practical necessities of life. But perhaps something subtle will be different. A slightly expanded sense of what's possible, what might be true, what existence might mean. Perhaps you'll notice boundaries more, appreciate depth differently, hold your own experience a bit more lightly, with more wonder. That's enough. Wonder is its own reward, its own kind of understanding. We've reached the end of our journey together, at least for tonight. We've explored ideas at the very edge of human knowledge, where mathematics meets philosophy, where physics touches consciousness, where certainty dissolves into beautiful uncertainty. Do we know that reality is holographic? No. The principle works mathematically in specific models, sheds light on black hole thermodynamics, offers potential resolutions to quantum paradoxes. But whether our actual universe is fundamentally holographic remains an open question. Future observations might confirm it, or might reveal something entirely different, and that's all right. The wondering itself has value, the contemplation its own reward. You've spent time tonight considering possibilities that expand what reality might be, how existence might work. You've entertained the thought that you might be a surface pattern dreaming itself into depth, information achieving self-awareness, the universe experiencing its own encoding. Whether this is literally true matters less than what the possibility opens in your awareness, a sense of wonder, of humility, of connection to something vast and strange and beautiful. As you drift towards sleep now, or simply rest in this quiet space, you might notice the strangeness of existence itself, that there is anything at all, that patterns can become conscious, that the universe can know itself through beings like you. This is the deepest mystery, whether holographic principles help explain it or not. Let the ideas we've explored tonight settle gently in your mind, not as truths to grasp or problems to solve, but as contemplations, possibilities, doorways into wonder. Let them become dreams, perhaps, your sleeping mind wandering through landscapes of information and boundaries, surfaces and depths, the cosmic hologram experiencing itself from infinite angles. The universe is larger and stranger than we know. Perhaps it's holographic, perhaps not. Perhaps our question itself reveals understanding's current limits. But the mystery remains beautiful, remains worth contemplating, remains worthy of our wonder. Rest now. Let your thoughts drift where they will. Whether you're a volumetric being in three-dimensional space or a surface pattern experiencing depth, whether your consciousness is localized in your brain or holographically encoded on cosmic boundaries, this moment is real, your experience genuine, your existence meaningful, your brief span of awareness a precious thing. The holographic universe, if it exists, dreams through you, and even if it doesn't, the universe still contains you, knows itself through you, achieves consciousness in your consciousness. That's enough. That's everything. Sleep well, and perhaps dream of surfaces and the infinite depths they contain.